equation, we get that Qi is equal to negative Qj plus the square root of 2Qj squared plus Qj, or Qj times the square root of 2 plus 1 over Qj minus 1. Anyways, that's all a bunch of algebra, not particularly interesting. But the key thing is that this reaction function is sort of going to play a similar role to supply or demand from what we did before. It's how much I produce given what the other person is producing. And so equilibrium is just going to come from the intersection between these for the two firms. So we can graph, here's how much guy J is producing, and here's how much guy I is going to want to produce as a function of how much guy J produces. Here's how much guy I is producing. Here's how much guy J will want to produce as a function of that. And these are just symmetric. They're just reflections of one another. And at the intersection of these is the equilibrium, where both produce 0.5, which is, 2 minus 1 over 2. Yeah, Matt?
All this stuff sounds really similar to the problem from this problem that we took today about, regarding, it's the end of one of the problems about the two symmetric competitors and the match virtual equilibrium.
Yeah, that was just foreshadowing
okay.
This class, exactly. Yep. So, I mean, that's exactly some version of this model. Okay. So if you read ahead, you get rewarded. Stackelberg argued. So that's the Cournot model. But some guy, Baron von Stackelberg, argued that one firm may be a leader in the sense that it can commit to how much it's going to produce, either by building its factories or by advertising I'm going to produce this much or whatever. And that will force the other firm to take into account what it produces, and then it won't be able to respond. So it can sort of commit to what it's doing. And the question is, what incentive does this create for the firm to change its production? Monica?
What incentives does it create for the firm?
The first firm. So imagine the firm can produce some amount, and then it can advertise that and tell the other firm that it's going to produce it.
What the other firms are going to do. They take that as given.
Exactly. Exactly right. So what is it going to want to try to get the other firms to do? Exactly. Exactly. Exactly right. So the follower, right, is just a monopolist on their residual demand, on the remaining demand in the market, and so they're just going to follow their reaction function from the leader, right? So if Qi is the leader, right, and this is the reaction of J, what is he going to want to do to reduce the amount that the other guy's producing? Well, this is an increasing function in this case, so he would want to reduce how much he produces, because that would lead the other guy to reduce how much he's producing. Exactly right. Okay, so there's a question, though, in general, about whether this requires raising or lowering production. In this particular case, it would require lowering their production. But Amanda, do you think that that's generally true? That the firm incentivizes the other one to reduce their production by reducing the production?
No, I think it depends on the company, and on the drugs they're doing.
Yeah. Yeah, that's right. So it depends on what's called strategic complements or substitutes. So if when I produce more, the other firm wants to produce more, then we say that we have strategic complements. If when I produce more, the other firm wants to produce less, we say that there are strategic substitutes. And this turns out to be driven by the pass-through rate. So in the case here, if the pass-through rate is less than 1, there's strategic substitutes. if the pass-through rate is greater than one of their strategic complements, constant elasticity of demand has a big pass-through rate, and therefore there were strategic complements here. But with linear demand, it would be the opposite. Yeah?
So are you saying that pass-through rate represents elasticities in this case?
No, it's not elasticities. It turns out this is independent of elasticities. So you can have the same elasticities, but if those elasticities are constant, you get one thing. If it's linear demand, you get the other thing. So, well, actually, I think we might go through, if not in this class, then in the next class, the example with linear demand, and it's going to be the opposite. Because our simple example was constant elasticity, that we had pass-through greater than 1. Okay, so let's solve everything out for the Stackelberg model in our case. Okay, so the quantity of the second firm is this, right? That was just that thing we had. And if we then say, well, let's add to that the quantity of the first firm, so we know the total industry production, that's going to give us just this expression here. So, David Guo? David Guo? No. Does anyone else want to just tell me what the profit is? If this is the total industry quantity, what would the profit be? No. Well, so the price, right, is 1 over this, right? And then my quantity is Q1. So if I take this, which is the price, minus 1, which is my cost, times my quantity, that's the profit. And that's the same as 1 over the square root of this minus Q1. Okay. Mariana, could you come down and take the derivative of that for us? You can do it. So we want to find the optimal quantity. One over square root 1 plus Q1. Okay, that's a plus there. Minus Q1. Yeah, you're taking derivative with respect to Q1. Very close. It's negative 3 halves, right?
Right,
This is
right,
negative-
yeah.
And this is
Yeah,
negative
yeah,
1
yeah.
half there.
Yeah.
Yeah. Perfect. And that's equal to 0, right? But you've got one extra thing, which is that you have to take the derivative of the inside. Yeah. Great. Exactly right. Okay, so that's exactly what she did, right? To the 3 halves, we've got the 1 half down there. Oh, no, she was, I missed the negative sign there. Sorry about that. Okay, well, anyway, I did this all in mathematics. I might have missed a sign on one of these. But if you plug this into Mathematica, you get that my optimal quantity is 0.1, whereas it used to be 0.5 beforehand. So it falls dramatically, right? Because I really can reduce the quantity that the other guy is producing by a lot by reducing my quantity. So that leads us to dramatically reduce the optimal quantity, right? And this is because the reaction function was sloping upward. With linear demand, you'd actually increase your quantity beyond 0.5, which is what you were doing in Cornell. So strategic complements versus substitutes, how the pass-through rate compares to 1 is really crucial and changes things a lot. Okay, so there's a few things to notice based on the quantity models, which is that even if we have a lot of firms in the Cornell model, for example, prices will still be above cost, right? Price is equal to, price minus cost is equal to 1 over n times elasticity, but it's not equal to 0, right? There's still some markup unless you have an infinite number of firms. And we'll talk on Tuesday about how as you get to have a lot of firms, the prices gradually come down. Prices between monopoly and perfect competition, prices will always be between monopoly and perfect competition. Because if the number of firms is infinity, right, then there would be price exactly equal to cost. On the other hand, when under monopoly, it's always equal to just 1 over the elasticity. As the number of firms increases, it gets smaller, but it's always in between the prices of competition and the monopoly. One of the more interesting results comes from when firms are not symmetric, which is different from what we considered. So imagine that each firm had a different cost, CI, right? And each firm will then set their QI times P prime plus P, that's the marginal revenue, equal to their individual cost CI, right? And notice that this means that lower cost firms must be producing more. Why? Because they have the same marginal revenue function as the other firms, but they have a lower cost, right? So this is lower, so in order for that to be lower, this Q is going to have to be greater because this is negative, right? Okay. So that's going to also mean that they must have a higher markup. That this whole thing here is greater, so the difference between their price and cost has to be greater. But that, because their markup is higher, the inefficient firms, which have higher costs, are still going to be producing some, right? And that's really inefficient, right? Under monopoly, the firm is going to minimize its cost for whatever it's producing. Under competition, everything's efficient, so everything minimizes cost. But under oligopoly, the inefficient, high-cost firms may still produce some of the product, and that's inefficient. So if we now sum this up across all the firms in the industry, we get the total quantity times P prime plus N times P is equal to the sum of all the firms' cost. And if we divide that through by N, that says that the average quantity that firms produce times P prime plus the price is equal to the average costs of the firms. And so that's going to mean that the pass-through of any of the firm's costs to the industry price is going to be like 1 over n of the normal pass-through rate, because each individual firm's cost increasing only increases the average cost by 1 over n. Right? And the key point here is that only the average cost in the industry matters. So this means that differences among firms are not that important in this model. It's only sort of the average firm that matters for the industry as a whole, which is very different than in the competitive model that we looked at, right? In the competitive model, it was sort of like the most efficient firm had a huge impact. Here, it's only the average cost of the firms that matter. And the one thing that's useful about this is it makes the model much more sort of robust to heterogeneous costs. We'll see that other models are going to behave very differently if the firms have exactly the same cost and versus having different costs, whereas here only the average cost matters. Okay, so basically what we've been studying so far, economists call a game. And what that means is it's a strategic situation with a small number of people where they're all making choices. Here the choices were about quantities and